Good morning, Year 5. Welcome to a brand new week of Maths virtual lessons. To get our brains warmed up this morning after the weekend, we are going to start with our mental maths. 4 questions on the screen, plus the shape to try and name if you can on the right-hand side of the screen there. Pause the video and give yourself 30 seconds now. Question number 1. Find the missing number. 0.36 add something, give me 1 whole. 36 hundredths, which is the same as 0.36, add something hundredths gives me 1 whole. The value I was looking for in there was 0.64, because 64 hundredths add 36 hundredths gives me 1 whole, or 100 hundredths. Number 2, which is larger, 0.709 or 0.82. When comparing decimals, I look at the highest value column first, which in these two numbers is the ones column. They both have an equal value of 0 in the ones column, so I look at my tenths column, the next highest value. I've got 7 tenths here, I've got 8 tenths here. So which is larger, 0.709 or 0.82? It's 0.82. Remember me talking about how to pronounce decimals and saying it's not 0.709 or 0.82. Okay, we've done so much work on tens, hundredths and thousandths, and this is a question, key question. You're looking at that without thinking, you might think, well, 709 is bigger than 82, so I must circle that one. You know now why that isn't the case and why we pronounce them the way that we do. So well done if you got 0.82. Question 3. What percentage is shaded? I have a bar which is labelled 100% and it's broken up into 10 equal sections. Each section, therefore, if I divide 100 divided by 10 means that each individual section by itself represents 10%. Because the bar has 2 shaded in, it's 2 lots of 10%. 10% add 10% would give me in total 20%. So 20% is the value shaded. Question number 4. Work out the area of the rectangle. If I'm working out the area of a shape, or a rectangle particularly, it's length times width. Because I've got my 2 labels here, 12 and 7, I merely times them both together. 12 times 7 is 84. Because I'm doing area and my 2 sides are labeled centimetres, my units of measure for this answer would be centimetre squared. Like so. The shape here shown on the right hand side is a hexagon. Well done if you scored highly. You might have even got full marks there. If you did, what a brilliant start to the week you have made. Fantastic. Already very, very impressed. Let's move on then. Today we're going to have a look at adding decimals with the same number of decimal places. We did a little bit of work on addition last week. This week we're going to take on our understanding a little bit further. Let's take a look at our first example. For our first example, I'm going to represent it both using a place value grid and also by using the column addition. We're going to use them side by side, a little bit like we did last week. First question here I've got 7.75 represented at the top of my place value chart, and underneath that I've got the value 2.46 shaded in. Draw my lines, put my decimal point in, don't forget my operation, which in this case is add. I always start with the lowest value column. In this case, the lowest value column is the hundredths column. So that's where I will start with my additions today. I can see there on the screen, hopefully you can see too, that we have got in total 11 hundredths. I've got 5 here, I've got 6 here. So because I have got 10 or more, I can perform an exchange. We looked a little bit at exchanges last week. I can exchange 10 of my hundredths. Let me select them all up. I can exchange those 10 hundredths for 1/10 because 10 hundredths is equivalent to 1/10. Think about that place value grid and all that work we did do with the 100 squares was it last week or the week before, we know that 10 hundredths, 10 individual squares is the same as 1/10, one row or one column. To show that on my column method here, I have exchanged 10 hundredths for 1/10, so I show my exchange on the line, preferably. You might do it underneath, but preferably I'd like to see it on the line. And because I've got 1/100th left over that I didn't exchange, the 1 goes here in the 100th column. I then move along to my 10th column. I've got 7/10 here, I've got 4/10 here, and I've also got my further 10th that I exchanged from my previous part of my calculation. So in total, I have got 12/10. Again, because I've got more than 10 or more, I can perform an exchange. So this time I'm going to select 10 of my tenths. 10/10 is equivalent to 1 whole. So again, to show that on my place value grid, I have selected 10/10 and I've exchanged it for 1 whole because they have equal value, so I can do that nice and easily. To show that on my column method, or in my column method, should I say, 7 add 4 add 1 we said was 12. I exchanged 10 of them for 1 1. I'm now in the ones column, and I have 2/10 remaining. My exchange 10th and my 1 remaining 10th. So in total I've got 2. To make sure I've added on that exchange, I'm just going to cross that out there like so I don't forget it. Now I've got my ones column to have a look at. I've got 7 ones here. I've got 2 ones here, and I've actually got a further 1 shown on my calculation here and also shown on my place value grid here. So in total I have 10 ones. I have in total 10 of my ones when I add them all together, which means because I've got 10 or more of anything, I can then exchange it for one of the next column. So I can select 10 of my ones like so, and I'm going to exchange them for 1/10. To show that on my place value grid, I have selected 10 and I've shown it by exchanging it for 1/10, 10 ones for 1/10. In my column method, I am going to show it by putting a 0, because I have 0 ones left, and I'm going to put my 10s straight into the 10s column. Why can I do this? I can do it because I have no further calculations left to complete my answer. So I can put my exchange straight into the next column. Cross out my exchange 1 so that I know I've definitely added it on to give me a final answer of 10.21. 7.75 plus 2.646, correct, sorry, gives me a value of 10.21. We're going to have a look at one further example using both the column method and using the place value grid. Dear, come on. Right, let's pull in the place value grid, which has already got my columns labeled and my counters in. So my example I've got here, I've got the example 3.10 hundredths and 8 thousandths. And in addition to that, I've got 2 ones, decimal point 1/10, 5 hundredths and 4 thousandths. So the difference this time is that my calculation involves thousandths. So when I think about where to start my calculations, I'm starting, if you remember from what I said last time, with the lowest value column, which this time is the thousandths column. That's where I'm going to start. If we have a look at how many thousandths we have got, we've got 8 here, we've got 4 here. So in total, we have 12 thousandths. Because I've got something great, 10 or greater, I can exchange, just as I was doing before, but this time involving my thousandths. I'm going to exchange 10 of my thousandths for 100, because 10 thousandths is equivalent to 100th. To show that on my place value grid, I've selected my 10 and I've exchanged it for 1/100th counter. To show it in my column, I would put that by putting a 1 here to show my exchange, and I would have a 2 here in the thousandth column because I have 2 remaining thousandths that I didn't exchange. And now in my 100th column, I have 0 hundredths here, I have 5 hundredths here, I have my exchange hundredths here. So in total, I have 6 hundredths. 1/10 add 1/10 is 2/10. 3/10 add 2/10 is in total 5/10. 3.108 add 2.154 is 5.262. Those two examples will help you with the first 4 questions on the worksheet today. So that will get you through the majority of the worksheet by looking at how the place value grid and the column method work side by side. And on some of the examples, you're going to have to draw in your counters and show me the exchange. So think about how you'll set that out, kind of using the logic of what I've just been doing there. Now, finally, just one more thing before I do let you start the lesson. We're going to have a look at perimeter. Now, why on earth are we looking at perimeter and we're looking at decimals and adding? Mr. Mills, you might be asking. Well, we are going to use this opportunity to help us recap our understanding of perimeter, which is something that we looked at before we finished school a good few weeks ago. So I'm using a different area of maths linked in to this area of maths to try and recap 2 things at the same time. How clever. So we looked at area in our mental maths this morning, and we talked about length times width when looking at trying to work out the area. Perimeter, though, is what I'm looking at now. Perimeter is the distance around the outside. If I've put on the screen there a rectangle, and I've labelled the length and I've labelled the width of the rectangle. If I was to ask you, what is the perimeter of the rectangle? I wonder if you'd be able to tell me. Just give yourself a couple of seconds thinking time and see if you would be able to work out quickly and mentally in your head how to work out the perimeter of that rectangle. If you're not sure, I'll take you through it now. If you're thinking that the perimeter of this rectangle is 16 centimetres, you're absolutely spot on. So brilliant thinking. Well done for coming to that answer yourself. If you're not sure, let me explain why that is the case. We know that in a rectangle, opposite sides are of equal length. So if I know that this bottom side here is 6 centimetres, I know that the opposite of that side is also 6 centimetres. If I know that the right edge here is 2 centimetres, I know that the left edge must be 2 centimetres. And then to work out the perimeter, we're adding up all of the outside labels. So 6, add 2, add 6, add 2. Or you might think, well, I can do 6 times 2, which add together these 2 and give me 12. And then I can do 2 times 2, which gives me 4, and then add my 12 and my 4 together to give me 16. Either method works. Okay, but just remember, the key thing to remember is perimeter, distance around the outside. That's what you need to learn and remember today. So your final question on your worksheet, question number 5, will require you to work out the perimeter. And it might involve using decimals to help you do that, because that's the main focus of the lesson, adding decimals. I'm going to leave it there now. I'm going to let you start the worksheet that goes alongside this lesson. Have a go at it. Let us know how you get on, and I will see you tomorrow.